Welcome again to today's session of Getting into Data Architecture from DI and DSF. My name is Sumakshi Chauhan. As Nicholas already mentioned, I work as a data architect at Euromonitor International. Let's get straight into today's agenda for the session. So I would be discussing about what is data architecture, what is its importance or significance, what are the key components of data architecture. We would also look into understanding the data ecosystem. Then we'd look into the data architecture frameworks, its patterns, what are the best practices to follow while designing a data solution or a data architecture solution. How does a data architecture journey looks like? Then I talk through the roles and responsibilities of a data architect. How can one become a data architect and what's next after data architect? So basically the career path. Then I would walk you all through some resources and then the Q&A session. Right, let's get started. So what is data architecture? And why is it important? Data architecture helps ensuring that the data is effectively collected, stored, processed, and made accessible to support the data-driven decisions. So it refers to the design, structure, and organization of companies or organizations' data assets. Now, when I say data assets, it means data sources, data storage systems, data models, data integration, and processing workflows. Now, what data architecture, why is it important or significant for any organization? Because it renders or supports or provides a solid foundation of data management, integration, processing, and governance principles and methodologies. It empowers or helps an organization to harness the full potential of their data and make informed and strategic decisions based on that. Now, looking at some key points of its significance, the very first one being data integration and centralization. So data architecture provides a framework for integrating data from various sources. The data sources could be external or internal. At the same time, it also helps to provide a comprehensive view of the organization's data, enabling the better decision making based on the new or the final updated information. Also, our data architecture includes data quality and consistency checks and validation mechanisms almost at all steps of the process. The third one being the efficient data processing. Data architecture defines data processing workflows and pipelines and how to optimize those data processing efficiency pipelines so that they can efficiently help in reducing the data latency and providing timely insights for the agile decision making. One of the key things while designing any architecture in general is the robustness. It's how the data infrastructure can scale and grow as the data grows, maintaining the performance even with the increasing data loads. And the last one, but of course not the least, is the cost optimization, because cost is something which is important to each and every organization. So an optimized data architecture can help in cost savings as well by streamlining the data processes, eliminating redundant processes and redundancies, and using appropriate storage and computing resources. Right. Now let's look at some key components of data architecture. So a data architecture comprises of several key components which work together to define how would be the design, what would be the structure of organization's data assets. Please note that I would be using the word data asset a lot many times during this session, which would simply imply to data sources, data integration and workflows, pipelines, data storage processes and data stores, etc. So the key components or the components ensure that the data is efficiently collected, stored, processed, and then managed and well utilized to get or achieve the business goals. So the very first one being the data sources. It refers to the various systems and applications databases and external sources which either generate data or provide data. So these sources can be internal to the organizations, such as databases like transactional databases or CRM systems, or it could be external like through the APIs. Second one being the data integration. Integration, as the name suggests, involve the process of combining the data from various multiple sources and transforming it into a unified, consistent format. So it basically ensures that the data flows smoothly between systems and enables a comprehensive view of the organization's data. Third is the data storage, which defines how and where the data is stored. It includes various types of data repositories, such as relational databases or RDBMS, data warehouses, data lakes, data lake houses, NoSQL databases, etc. Now, the choice of storage depends on the what type of data it is, the nature of the data, and what are the requirements for the data processing. Next up, we have the data models, which represents the logical and physical structure of the data. They define the relationship between data entities and attributes, facilitating the data understanding and efficient retrieval of the data. So these includes the entity relationship models, dimensional modeling, NoSQL models, etc. Now, data processing involves the transformation and analysis of data to extract valuable insights out of it. It includes data transformation, data aggregation, cleansing, data enrichment, and various other manipulation operations. We would be looking to some of these components again in our upcoming slides. So the next one is the data governance, which is governance, as again the name suggests, it is to establish policies, guidelines, rules for the data management. And why are we establishing these policies, guidelines, and rules? Just to ensure that we are having a good quality data, where the data is secured, we are maintaining the privacy of it while being compliant with the regulation of that particular country. Next up is the data security, which addresses the protection of data from various unauthorized accesses or any attacks. It includes things like access controls, encryption, and other security measures just to safeguard the sensitive data. The next is the metadata management. Metadata, as we are already, most of us might already be aware of, which is data about data, which it includes information about data such as data lineages, systems, data lineages basically where we can track the information to the original source and how the data was modified from original source to the endpoint or to perform the analytics. So data lineage is one such system which can help us in tracking all of those details. This metadata management also includes data definitions, data source and transformations. A good data management helps an organization in data discovery and understanding and traceability. So if, for example, we need to track back on certain type of data for in order to check whether how well we are doing with the sales. Generally, this comes up under analytics projects, but just to have an internal check of how well our sales are performing, we can use the data lineage systems and perform the analysis over it. Next up is the data catalog, which is the centralized metadata management tool. It is considered, it can be considered as a centralized repository, which stores the metadata and provides searchable inventory of available data assets we have. And the last being the data architecture governance, which involves overseeing the implementation and either we are sticking to the data architecture standards or not. Are we following the best practices and guidelines across the organization or not? This is all what's been taken care at data architecture governance. Right, now we have learned what data architecture is, what is its significance, its key components. Now let's dive deeper into understanding the data ecosystem. So when I say data ecosystem or understanding the data ecosystem, a data architect can help an organization to effectively design, implement, and manage their data assets, ensuring that data is accessible, reliable, scalable, and usable for strategic decision making. Now, what happens is data architecture, data engineering, and data governance are distinct yet interconnected disciplines of data management within the data management domain. Each of them have their own significance, and each of them plays a crucial role in ensuring effective data utilization and governance within an organization. But we often get confused between these three terms, and we tend to use them interchangeably at times, which is slightly wrong, and we'll understand why. So data architecture, as I mentioned before, refers to the design, structure, and organization of companies or an organization's data assets. Uh, it includes the high-level blueprint of the data ecosystem, which includes data sources, data models, data pipelines, etc. So data architecture focuses majorly on creating a comprehensive data framework which aligns with the business needs. It does involve a lot of strategic planning and design for the data landscape. While data engineering involves the implementation and management of these data pipelines and transformation workflows, or the ETL pipelines from various data sources to the storage repositories. So we can, in a way, say that data engineering or a data engineer focuses on the practical implementation of what a data architect designs by building and optimizing those data pipelines, ETL processes, data transformation logics. And a data engineer ensures that efficient data movement, data processing, and data storage is being done, while these are being originally designed by the data architecture. Now coming to the data governance, it is the process of defining the policies, set of rules, standards, regulations for maintaining the quality and security of the data. The sole purpose of governance is to ensure that the right use of data is being done, along with its while maintaining its security and integrity within the organization. It ensures that the data is trusted, reliable, and compliant. So all in all, neither of these roles can work independently and bring success to the organization. So all of the three areas or all of the three roles collaborate with each other to establish a robust data management framework, which in turn enables an organization to make informed data-driven decisions while maintaining the data integrity and security. I hope now we have a clear understanding of how data architecture is different from data engineering and governance. Let's look at the data architecture frameworks now. So data architecture frameworks or frameworks in general provide a structured approach to organizing and managing data within an organization. These frameworks offer a set of guidelines, principles, best practices of how to design, implement, and maintain the data systems or systems in general. There are top three popular data architecture frameworks. The first one being the TOGAF, which is the Open Group Architecture Framework. Now, I would like to mention that this is not just limited to data architecture, but it is a very generic, comprehensive framework used for the enterprise architecture. It consists of various phases, such as architecture, vision, business, data, application, and technological architecture. So it has various phases and components in it. And the sole purpose of this TOGAF framework is to promote the standardization and to enhance the decision making by providing a clear roadmap for the projects. The second framework here is the Zachman framework. It's personally one of my favorite frameworks because it helps personally me to maintain and document all of the expectations and documents from the business stakeholders. So what this framework states that it helps in understanding and documenting the relationship between various viewpoints of the data architecture. It provides us a holistic view of into a matrix of how, why, what, were, who, and why, how people were involved, and why are we doing a certain process, how would it be done, who would be responsible to take care of it, who would implement it, and why are we doing it. So it is all represented in the form of a matrix, where across each matrix, we do also mention the different stakeholders like planner, owner, designer, implementer, operator, and contractor. So what this framework does is, it would, if every time, let's say I uh, speak to a business stakeholder, I can easily understand and document what I could get uh, from the from that particular meeting. And it also gives a clear view to the business stakeholders in terms of what's been agreed upon to implement, and why are we doing certain sets of uh, operations, or certain sets, why are we implementing particular data store and not any other technology. All such questions are being answered through that particular document itself. And the third framework being the DMBOK, which is the data management body of knowledge. It is a comprehensive reference guide for the data management practitioners. It covers all the aspects of data architecture, ensuring that the data is well governed, secured, and is of high quality. So it has been structured into 10 knowledge areas. Each to name a few of the areas are data architecture, data governance, data modeling, data design, data quality, metadata management, etc. So these are the three famous data architecture frameworks. I would like to highlight here that TOGAF and DMBOK, both of them conduct their exams for the certifications. These certifications are widely accepted across the industries, and these certifications does hold great value. Reason being, not everyone clears these exams, and these are not easy to. I would consider or say that these are moderate to difficult in terms of difficulty of certification. So please go ahead and check those out if you want to pursue any of these. Let's look at the data architecture patterns now. Again, data architecture patterns are standardized and the proven solutions for organizing, managing, processing data, storing data within an organization. Now, these patterns helps us to address the common data-related challenges. It also helps us to bring in consistency, validate consistency, scalability, and reusability in a data architecture. So there are so many other data architecture patterns in general, which I am not going to mention in this session, such as microservices, architecture patterns, etc. I believe that these are the 6 main ones which we should be discussing and are relevant for this session. The very first one being the centralized data warehouse. So what happens in a centralized data warehouse? All the data from various sources is extracted, transformed, and loaded into a single centralized data warehouse. Now, this approach helps in unifying and viewing the historical data, which makes it easier for the business users to perform complex queries, generate insights out of that data. It does also have some conditions on when to use the data warehouse, when not to use the data warehouse. It all again depends on what are the business needs, what is the data requirement, and all sorts of business questions that we need to answer before deciding on which data architecture pattern should we use. Next up is the data lake, which involves storing raw, unstructured, all sorts of data. By all sorts, I mean the raw data, unstructured data, or structured data from various sources into a single repository. So and these allow the organization to store the vast amount of data in its native format without requiring a predefined schema. Now, how does this help? Let's say we want to perform an analysis over something where we need the structured data, or we don't have to worry about the structure. So we do have data lakes does provide this flexibility of we can structure the data as and when and how we need it based on the business requirement. These are generally used for the big data analytics projects and ML use cases. The third is the Lambda architecture, which combines the batch and the real-time streaming to handle both the historical data and the real-time data. It primarily has 3 layers. The first one being the batch layer, which includes the historical data. Then the second is the speed layer, which consists of the processing of real-time data. And the third is the serving layer, which combines both the above two layers, the batch layer and the speed layer, in order to serve the results. This is primarily used for the querying and serving the results. So this type of architecture is generally used for applications where we need both the real-time and batch processing at the same time. Next up are the event-driven architectures, which focuses on reacting to the events and messages generated from various systems or sources in real time. So these events are sent to the there's one central service bus where events are sent, and multiple consumers can process these events independently. So it offers a high degree of parallelism without affecting work from any other events. The fifth one is the data mesh, which focuses on decentralizing the data ownership and governance. It breaks down the data capabilities into domain-specific data products. And each of these domains are being managed by the domain experts. And the next one is the master data management, which does exactly opposite of what data mesh does or proposes, which is focusing on single source of truth, creating and maintaining just one piece of master data, which an organization should refer to ensure consistency, integrity, and accuracy across the systems and applications. So these are the widely used 6 data architecture patterns. Now we would be looking at the best practices of while designing the data solutions or while taking the data architectural decisions. The first one being understanding the business objective. We should always ensure that the data initiatives and investment supports all the overall business strategy. We should always take care of that the decisions that we are taking in terms of the data, the technologies that we are using, or let's say the data storage that we are using should be aligned with the business goals. We should always think about and remember the long-term goal of why are we doing that data architecture design? Why do we need to do that? And what are the pitfalls, or what are the disadvantages of the current system? We should never forget those while designing our data architecture design. Next up is the data governance, which is establishing robust data governance processes to manage the data quality, security, and always stick with the compliances. Third is the data modeling, which is, again, using the right data model techniques to design the logical data model so that we can accurately represent the business entities, attributes, and relationships. Uh, uh, Again, we would need to always, and we should always consider both the current and the future needs when designing the data model. We should always be taking care of that our solutions are scalable and future-proof. By future-proof, I mean we should avoid making rigid solutions that may become obsolete quickly, or we should our solution should be flexible enough to adapt to the changing world and its technologies. So the next is data integration and security, which is implementing effective integration strategies to enable seamless data flow across the systems and applications, while protecting the sensitive data from breaches and unauthorized accesses. Data storage and compression, we should uh, always look out for all of the data storage options before deciding on why and what do we need to do in terms of choosing the data store. So next up is the data backup and recovery, which is implementing the right data backup and recovery plans to ensure that data availability to ensure high data availability and minimize the data loss in case of faults. Next up is the performance monitoring and optimization, which is, of course, data architecture or designing data solutions or solutions or architectural designs are not a one-time thing. They always need maintenance, and they would need to always be look after and check whether the design that we did, let's say a year ago, still meet all the business needs or not. So now let's look at how does or how does a data architecture journey look like. It starts with understanding the business objects or objectives and requirements, which is thoroughly understanding the organization's business goals, objectives, and data related needs, and then collaborating with business stakeholders to identify the data requirements, what are the desired outcomes from that particular architecture, answering questions of what are the long-term goals and the short-term goals that the business wants out of that data architecture. Once that's been done, then we go on to building a data strategy, which is again based on the business requirements, translating those business requirements into technical requirements. Uh, this data strategy defines on how will the data be managed, stored, processed, and utilized. It outlines the vision, goals, the key performance indicators of the architecture that we are proposing. Once that's done, we conduct an assessment of current data landscape and identify the gaps for improvement, whether we can make some quick fixes in the current architecture and get it going, or should we completely change the architecture uh, due to our changing business needs or uh, our different long-term goals. Because changing a complete data architecture means it does involve a lot of money. So we need to think about that wisely. Once we conduct the assessment of the current state and identify the gaps, we then establish the data governance frameworks to define who would own the particular data source, or what would the data ownership look like, what would be the policies, what would be the data quality standards that our organization should have all the times. Once those data governance frameworks uh, or policies are established, we then look out for the data architecture principles, which are nothing but the taking care of the key components of the data architecture, which we discussed earlier. It also looks after for it's considered as a designing guide and implementation for the data strategy, which we built right after discussing our business objectives with the business stakeholders. Once we have the data architecture principles in place, we then start designing the logical data models, which represents the core business entities and relationships. This is where we use the lucid charts and all sorts of diagramming tools to design the logical models. Once we design the models logically, then we choose next up is to choose the data storage technologies based on the data requirements and the business requirements or the business goals. Once we design the data models and choose these data storage technologies, then we look out for developing the data integration strategies on how those data from various data stores would be connected. How would we ensure that there is a seamless data flow between different sources and systems? Once we have planned the ETL and the integration of these different data sources and applications, then we look out for implementing the data security measures on. Now we know, okay, we have, let's say, 10 data sources. We know how we are going to connect them and how would the data flow across each of them. But we also need to ensure that all of those 10 data sources are secured. All of those 10 data sources have appropriate encryption, access control methods, etc., just to safeguard the data for an organization's data. Once we have the data security measures in place, we then look out for uh, implementing a POC. So before implementing any solution for across the organization, we first implement or build a proof of concept to validate the feasibility and effectiveness of the data architecture that we are proposing. Um, it is always advised to build a proof of concept before rolling out the solution or directly implementing the changes of data architecture into the organization. Once we have once we did the proof of concept and we get the desired results, then we need to look out for that in order to implement that data architecture, we need to be very cautious of how we are doing it. It should be in a very iterative manner where we are addressing the critical components first and then gradually expanding on that architecture, which means that we are slowly building on top of each layer instead of directly uh, jumping onto building each of the layers all together in a go. Once we have the data architecture in place, then we look out for the data quality checks and data profiling processes, which is, uh, remember, we set some data quality and um, data data quality standards that we set during establishing the data governance framework. Now those standards would be in use, and we would check out for what is the data quality that we've been getting after implementing our new data architecture, and how can we improve on our data quality. Once we do that, uh, again, it's a continuous process. So we would need to continuously keep monitoring the performance and effectiveness of how well our new data architecture design or new data architecture is doing, and optimize the architecture to improve its efficiency. It is, of course, an ever going or always going ongoing process. Uh, and one thing that we need to take care of is that as the organization is growing, as the data needs is changing, as an organization is bringing on new projects, expanding its horizons, then we need to be sure that the data architecture that we designed can be evolved and can be scaled to meet those new requirements. Along with this monitoring and optimization, we would also need to train and educate the business stakeholders and people who are uh, somehow related to that particular architecture. Reason being that they should be aware of why are we doing a particular set of work. It is very important for a data team to educate and train the other members in the non-data team members on how and why they are doing a particular set of tasks when it comes to the architectural side of things. Right. Now we will look out for the roles and responsibilities of a data architect. So most of them I've already explained, but I would still, one thing which I didn't explain or talked much about in this session so far was the data strategy. So data strategy in short refers to a well-defined plan that outlines how an organization, how a company will manage and leverage its data assets to achieve the business objectives. How would they use the current data systems and applications they have in place and make best use of it. So let's say we are designing a master data management solution for an organization. Then a data strategy would not only include information like what data stores would it have, what all pipelines would it have, but it would also be having it would also have information like how would that master data management be adopted in different countries based on their policies and regulations. Now, this is where this is a classic example of how a data architect, data engineer, and a data governance, someone working in data governance would work together just to have an effective master data management solution. So this master data management solution would include would include the key performance indicators of the how well this master data management was adopted, such as what would be the percentage of duplicate data after 1 year of the adoption of this new data architecture or new metadata management system. What would be the mean time to repair the data issues after we adopted this new data metadata management. Right. Apart from that, we have already discussed points like data modeling, data integrity and security, technology selection, which is why are we selecting a particular tech stack? Why not the other suits? Why not any other technology available from that suite? Collaboration is one such thing which is very important in specifically in the data architecture role. Reason being, there's not even a single day when a data architect would work just solely without collaborating and contributing uh, with data engineers, data scientists, and business stakeholders. So communication is definitely one of the key things to look out when preparing for this role, because you need to be very effective with communications, because you would be the person who would be converting the business requirements to data requirements. So in short, you would be speaking to the business stakeholders, which could be technical or non-technical, and then you would be translating those needs to data teams. You would be working alongside those data teams. So you should be well versed with data engineering principles, data science, and analytics, of course. So, and one of the other thing being the data architecture documentation, which is again a very important documentation. I personally like to follow the Zachman principle, which framework, which I discussed earlier in this session. Uh, it not only helps the organization to keep a track of what's been done and what needs to be done, but personally, as being in this role, it also helps me to maintain a log of why I took that particular decision, let's say a year ago. So data architecture documents are very important for this role, for both the organization and the individual working in that role. We look at the career path of data architect. So someone who is very new to the data field can start with being a data analyst or engineer. Why data analyst or engineer? Because getting into data would always start with analyzing it, learning what data is, what information is, how to clean it, how to analyze it, how to perform EDA over it, or how to model it is the stepping stone to get into data. So someone working in data analysis or data analyst or engineer would have a knowledge of how does the data work, how to integrate data from various systems or sources, how to design pipelines. Once someone has done that, they are good to go with being a data modeler or a junior data architect, which is where they are responsible for designing the data designs. They would be responsible for designing, modeling the data, choosing the data stores, and defining the structure of the data. Once that's done, people transition to the data architect role, which is again a combination of everything that we learned previously from being a data analyst to a data modeler. On top of this, the added responsibilities of a data architect is engaging a lot with the stakeholders and business stakeholders, converting the business requirements into data requirements. So basically converting the business documents to data documents. This then transitions into the senior data architect or lead data architect, which works on a similar line as a data architect, but with more responsibilities or added responsibilities, which can finally transition into two roles. First one being the chief data officer or the enterprise data architect, which looks after the complete data of an organization, who is responsible for making decisions on which projects to go for, what type of data to look out for, and all such questions. And the other one being the consulting or the executive roles, where these are more of consulting ones are more of the freelancing roles, where such experienced person is eligible or holds great experience to consult on any of data related projects.